to approach these from a calculus standpoint, because this is a pre-calculus class. And the thought is that you will all be at some point in your lives taking calculus. So we're going to look at this as a calculus student, which is different than you've looked at them before. Abby Brady, you still owe me 2 boxes of Kleenex, so now you're chewing gum. Again. Did you bring the 2 boxes that you owe me? Okay, I'm going to enter a detention for that, and now you owe me a box of Kleenex for these, okay? Or we'll just have another detention, okay? Now, I'm not going with 3 boxes, so you won't remember.
Did you bake cookies?
You were in the other class when we did that.
Okay. Now, here's what I want you to do. I want you to think of this problem as a distance. Now, just put your pencils down and listen to me for a second. Then we'll pick them back up and we'll get started on this. But I just want you to think for a second. If I had a number line and I put 5 and 12 on the number line, and I said to you, how far apart are these? What's the distance between these 2 numbers on the number line? You would all say what? 7. And you got 7 by doing a subtraction problem, right? So when I see a subtraction, I think of that as a distance. This is the distance from 5 to 12. Would you agree with that?
Yeah.
Now, we subtract usually big minus little. But if I subtracted the other way around and said 5 minus 12, as long as I took the absolute value of that, would that be the same as this?
Yeah.
So when I do a distance, it has to be positive, right? If I say how far is it from home to school, you don't say negative 18 miles, right? It's a positive number. So to guarantee that our distance will always be positive, we can put it in absolute value. Then it will always be positive, right? So I want you to look at this. This says the distance between 12 and 5. So what does this say?
The difference between X and 2.
The distance between X and 2. That's exactly right. So if I had my number line and I put 2 right here, then the distance between some number and 2, because X I don't know, so it's some number and 2, has to be 3.
Or greater, will it be greater than 3?
Well, it's going to be greater than 3, but I'm going to start with 3 to set my cutoff. So I'm going to say, okay, it could be 3 units this way, which would put it at 5. Or it could be 3 units this way, which would put it at negative 1. So these are the places that are exactly 3 units away from 2. Would you understand that? Does that make sense to you?
Mm-hmm.
Now, but like Gibran has pointed out, I don't want to be exactly 3 away. I want to be more than 3 away, right? Greater than 3. So will that be in between these 2 numbers, or will that be beyond those 2 numbers?
Beyond.
Beyond. So the answer to the question is everything less than negative 1 or everything greater than 5. 5. No, that's actually easy. That's not difficult. That is so easy.
I know, but it was easier than algebraic.
I think this is a lot faster. All right, let's practice another one. I got kind of tricky on the sheet here. Just did a bunch of tricky ones. Let's do another easy one. So over to the side, put this problem in. So let's try this. I'm making this one up. We're just doing this one extra over to the side, okay?
I go to the board and kill this problem.
Okay, well, just wait a minute. I promise you'll get a chance to run, but there's still some people a little confused, so I want to walk through this way. Okay, it says the distance between something and 4. So notice I'm going to put 4 on my number line. The distance has to be less than 5. So what do? I count out 5 this way and back 5 this way, right? So what will be those boundaries? If I go 5 this way, I would be at 9. And if I go 5 this way, I would be at -1. Now, there's an or equal to this time, so I'm going to have solid dots at those two numbers. Right? Now this time it says that we want the distance to be less than 5. So if we want to be less than 5 away, we won't shade the outsides. This time we'll shade the inside. Does that make sense to you?
Mm-hmm.
So your answer is everything between -1 and 9. All right, let's do one more of these easy ones, and we'll look at the rest of them on the sheet that have just wild variations. Okay, now this says the distance between x and 10. So I'm going to draw a number line, and what number am I going to put right here in the middle of the number line?
10.
A 10. And then I'm going to start at that 10, and I'm going to count forward
12.
2, which would put me at 12,
And then 8.
and backward 2, which would put me at 8. Will those be open or closed dots? Closed dot, it's an or equal to. And then I'm either looking at the numbers in between my two dots, or I'm looking at the numbers beyond my two dots. This time it's beyond, because the distance has to be greater than. Greater than pushes us out, past. So your answer would be everything less than or equal to 8, or everything greater than or equal to 12. Now let's look at, back to the sheet now, let's look at B. Because I got tricky, does anybody see anything different? It's what? It's a plus sign. It's a plus sign. Does anybody have a thought about how I'm going to interpret that plus sign in terms of my number line? Well, so where am I going to put my starting point?
-5.
I heard some people say -5, and they are correct. Look here, where did I put my starting point here? 4. Where did I put it here? 10. So where do I put it, Maya? The opposite. Because technically, this is x minus -5. We never write it that way, but that's what it is. So my dot has to go at -5. It goes at the opposite of this. And then I will do everything the same. So I'm going to count forward how many? 6, which would put me at where? 1. And then I'll count backward 6, which would put me at -11. Those will be closed dots, correct? And then I have to decide, am I going to shade inside or outside? What do you think? Inside. Less than means inside. It says keep close to the number. So your answer is everything between -11 and 1. When you write this answer, when it's like a closed interval like this, make sure that you put the 11 first and the 1 last. And these symbols will always be less thans.
Do you have to put brackets around it?
No, you don't have to. If you wanted to use interval notation, we talked about that. You could do it this way if you wanted to. And of course, if you want to do this, it's fine,
Wait,
but you don't have to.
You could do the instead of that or both, because I keep messing up on
One or the other. You don't need to write it both ways. One or the other will be fine. Okay, let's look at the next one, because I got tricky on the next one too. What's different about this one, you guys? You have a number on the front. Any ideas what I might do if I don't want that number there? Divide it out. Trust your gut. You are correct. Divide it out. So now okay, there's a lot of chatting, and it better be about absolute value inequalities. Gibran? Or Gibran, as they said your name on the radio the other night.
Gibran.
Okay, so I have divided everything by 2. So now I'm going to draw my number line, and what number am I going to start with right in the middle of the number line? 4. This is my starting point. And then I'm going to count back and forth 7/2, which is 3.5. So if you function better counting forwards and backwards in a decimal form, that's fine. This is 3.5, so we're going to count forward 3.5. So where would this boundary be? 7.5. Where would this one be?
1.5.
Be careful. Just 0.5, right? 4 minus 3.5 would be just a 1/2. And then what's the last thing we have to decide?
If it goes,
We shade, oh, yeah. I need dots, so there'll be closed circles. Then I need to decide if I'm going to shade in between the dots or outside. This one would be outside. Greater than means outside. Greater than means farther away. So my answer is everything less than or equal to 0.5 or greater than or equal to 7.5.
do you always divide by the X?
Now let's take a look at this next one. I got a little carried away, but you know, I do expect you guys to be able to do everything all the other pre-cal classes can do. So I gave you a really hard one here. This is as totally hard as they could possibly get. A couple of things wrong with that. First of all, what seems odd to you about that?
The X is after the
The X is after the 3, and that seems backwards to me. Does that seem backwards to you?
That seems totally backwards.
So guess what? I'm just going to turn them around. Now, I heard somebody say, really, is that allowed? Well, of course, Mrs. Ford would never do something that's not allowed. But here's why it's allowed. As long as we take the absolute value, would you agree these two things are exactly the same?
Yes.
So if I don't like the order that it's in,
You just do what you want.
I just do what I want. I just turn it around.
She said, I don't feel this.
I am only allowed to do that. I'm only allowed to do that because I'm an absolute value. When you are an absolute value, the order doesn't matter because everything's going to end up positive anyway. Okay? Now, I still don't like the way it looks. It looks better now, but I still don't like it because there's the 4. So I'm going to divide everything by 4. Maya?
So what happened to your negative sign that was in front of the 4? Or does it not matter since that?
When it got turned around. 4 minus 3 is the same as 3 minus 4 as long as I'm an absolute value.
Okay.
So I'm allowed to just switch it. Now, in normal subtraction, you're not allowed to switch it. But I am an absolute value, so I am allowed to switch it. Okay? Now, here's my number line. What number goes in the middle of the number line? 3/4. Now I'm going to count forwards and backwards 3/4, or how much? Not 3/4. 9/4. So 3/4 plus 9/4 would be 12/4, right? Which is 3. How about 3/4 minus 9/4?
Negative
3/2.
3/6.
Negative 6/4, which reduces to negative 3/2.
It's an open circle,
Open dots at those two boundaries.
and you're going on the outside.
inside. Less than is inside.
Oh, inside.
Less than is inside, that's right. Less than, think of it like this. Less than means closer to, it means less distance. So my answer would be everything between negative 3/2 and 3. Or if you like the interval notation, you can write it like this. If that's easier for you. So today we have two kinds of inequalities to talk about. That's one kind. We've done 6 examples. And we do them all exactly the same way. Okay? Now, the next kind of examples are different. These are called polynomial inequalities. And I bet you have an idea how to start that problem. Factor, very good. You're all over it today, Brooke. Good job. We're going to factor it. So does anybody see how this one factors?
1 and 5.
So x minus 5 plus 1?
Yeah.
Now, just like before, I'm going to go to my number line. And I'm going to put 2 dots on my number line. Exactly. I'm going to put -1 and 5 on my number line. Remember a minute ago how we put the opposite of this on our number line? Remember how we did that? See how I'm doing the same thing here? I'm putting the opposite of those 2 numbers on my number line. Now, make sure they're in the right order. On the number line, -1 comes before 5. Okay? Now, I need you to pick one number. 21. It doesn't matter. 21 is a fine number. Would you agree 21 is out here?
Yes.
All right, now here's what I need you to do. Pay attention. If I take the number 21 and I put it into this parentheses right here, if I put 21 in there, what do I get?
21 minus 5 is 17.
16. Right? And then what do I get here if I put it in here?
22.
So this would say, if you put in 21, which is a much bigger number than I would pick if I were doing it, but it's okay, every number will work. If we put 21 in both of these parentheses, we would get 16 times 22, which is some big positive number. Would you agree with that?
Yes.
Now the problem says, when I multiply these together, I want to be bigger than 0. Bigger than 0 means positive, doesn't it? If we put 21 in, didn't we get a positive answer? That means that 21 and every other number out here is part of the solution set. Because these numbers, if I put them in, make it positive. Okay? Any number you would have picked out here would work.
What if it doesn't?
Well, if it doesn't work, then we don't shade it in. So let's suppose I said to somebody else, pick a number, and somebody else picked 4, the number 4. Now the number 4 is in here, right? So if I put 4 into my parentheses, I get -1 times 5. If you put 4 here and 4 here, you see that? Now what happens when you multiply -1 times 5? You don't get a positive number, do you? So this is not part of the answer. There's no answers there. What if somebody else would have picked -3? Well, -3 would give me -8 times -2. Does that give me the kind of number that I want? Yes, because what kind of number did I want? Positive. This whole problem is about being greater than 0. That means positive. So this part would work too. Now I want you to notice something that will always be true. At least in the problems I give you, it will be true. See how this section gave me good answers? This section did not, and this section did. They'll always alternate that way. So if you tried a number, let's say here were your 2 dots. If you tried a number here and it didn't work, then this number would, and this one wouldn't. So basically what I'm telling you is, you don't need to check 3 different numbers, you only need to check 1. And then you know they alternate. Well, let's do some more problems, but first of all, let's write the answer to this one. The answer to this problem is everything less than -1 or greater than 5. These numbers worked, and these numbers worked. All right, that's our first example. I know that you're a little bit flabbergasted.
How exactly does anything less than -1 make it greater?
Can you still do -1, 5?
Because if you put in a number less than -1, it will make this parentheses negative, and it will make this parentheses negative. So when you multiply the 2 parentheses together, you will come out with a positive result.
Can you still do the, like just write -1 to 5 instead of that? No, you have to write it on the
Because that only works if you're talking about in between the 2 numbers. All right. Listen, this is intense, but we gotta get it figured out. I wanna start reviewing. We gotta get through this stuff. We still have some word problems to do. So, here we go. Here's our problem. What is step 1? Factor. So let's figure out how to factor this one. What are your thoughts?
-1.
X plus 10, x minus 1. Is that okay with everybody? What's our next step? Number line. We're going to put 2 numbers on our number line with nice solid dots this time. Solid dots. Where will the 2 numbers be? -10, +1. Now we pick 1 number. Any number you want except the dots. You can't pick the dots. Any other number. 5. All right, let's pick 5. 5 is out here, correct? So I'm going to put 5 into my parentheses. I get 15 times 4. Now that's a positive number, isn't it? What kind of number do I need in this problem, though? I need negative. Boys and girls, less than 0 means negative. Will 15 times 4 give me a negative answer? No. So these aren't going to work. Cross it out. That's not going to work. I just got done telling you, though, if that section doesn't work, what about this section?
Yeah.
It's going to work. What about this section? It's not going to work. So this time, our answers are all of the numbers in between -10 and 1, and Katie, this one can be written that way because it's the numbers in between. Will?
Wait, how do you know the left side won't work?
They alternate. The sections alternate.
Oh, okay.
And the problems I give you, that will always be true. That is not true of the whole wide world, but.
So 0 is negative in this problem?
Less than 0. This says less than 0. Less than 0 is negative. Greater than 0 is positive. All right, let's try another one. Okay. Step 1, girl table over there, except Jared. Jared and girl table over there. What's step 1? Katie, Maddie, Veronica, Jared, somebody. Factor. Okay, girl table except Jabron. Somebody at this table tell me how that thing factors. X minus 5 plus 2? Okay, boy table right here, tell me the next step. What?
Number line.
Number line, yep, draw the number line. And what are the 2 dots that are gonna go on the number line table here? What are the 2 dots? -2 and 5, make sure you put them on there in that order. Girls, what do I do next?
Plug in a number.
Plug in a number. What number do you want, Julia?
7.
7. 7 is the number out here, right? And remember, you can pick any number you want except the dots. She chose 7. If I put 7 into my parentheses, I will have 2 times 9. If I put 7 in, 7 minus 5, 7 plus 2. So I get 2 times 9, which is a positive number, right? Is that what I want this time? Do I want a positive number? No. This means negative, kids. Less than 0 means negative. I want numbers that make it negative. So this doesn't work, which means what? This one will, and this one won't. So my answer is all the x's between -2 and 5. And Katie, since that's a between one, you can write it as an interval if you want. Maya?
I put in 4, and then I got -1.
Okay, right. 4 is in here, and that gives you -1 times 6. Does that give me the kind of answer that I want? Yes. Yeah, so you shade it. That's what I did. Mine was shaded too. Now E. What's different about this guy, you guys? Oh, wait.
Cubes.
I think I skipped D, but that's okay. We're going straight to E. What's different about it? It's got a cube. Okay. Oh, good. We're going to take out an X. Remember, Jabron, remember, factoring is the first step, period. I don't care how big or little the problem is, you want to factor it. So since that's a cube, Tim noticed that I can take an X out of everything. Okay. So I will take an X out of everything. That leaves me with X squared minus 2X minus 8. Now, does this part factor? Notice I'm bringing my X along for the ride. How does this factor?
4 and 2.
Minus 4 plus 2? Now what's going to be different? Here's my number line, but what's going to be different this time?
You're gonna have 3.
I'm going to have 3 dots. That's exactly right. I'm going to have 3 dots. Clearly I'm going to have a dot at 4 and a dot at -2. And there's a dot at 0. Perfect. This X sitting out here all by himself with no number means he's a 0. So I have a dot at -2, a dot at 0, and a dot at 4. Now, guess what you do? Same thing. Pick a number. What number do you want to pick?
2.
2. 2 is in here. Pay attention where you are. 2 is in here, right? So if I put 2 in for all of my x's, I will have 2 times -2 times 4.
Yeah.
Now when I multiply those together, I get a negative number, don't I?
Yep.
Is that what I was looking for?
No.
What's greater than 0 mean? Positive. I'm looking for positive. I got negative, which means that didn't work, did it? Now what does that automatically mean? If that one didn't work, this does. How about this one?
No.
Oh, yes it does. That one didn't. How about this section? No. They alternate. Work, don't work, work, don't work. So as soon as we knew that one didn't work, then we knew these two had to, and that one didn't. So now what's my answer? Well, it's everything in between -2 and 0. This section right here, everything in between -2 and 0. Or everything greater than 4?
Yeah.
Because those were the two sections that we ended up with shading.
instead.
I'm gonna do the next one, so write the next one down. All right, now I'm looking at F.
I think she did.
Now, if you've been paying attention, you know exactly what we're going to do first. Or take out an X. What will I be left with if I take out an X? X squared minus 1. Now, does X squared minus 1 factor?
X plus 1, X minus 1.
Very good. X plus 1, X minus 1. Perfect. How many dots will be on this number line? 3. And where will they be?
1, negative 1, and 0.
1, negative 1, and 0. Make sure they're in order. They're closed. Now what? Plug in a number. What number shall we choose?
2.
2 or 3 doesn't matter, but they're both out here, right? I'm just going to do 2 since it's smaller. So if I put 2 in for all my x's, I have 2 times 3 times 1. I'm putting 2 in. That gives me a positive answer, doesn't it? 6. Is that the kind of answer I wanted? No, this means negative. This means I want numbers that give me negative answers. 2 gave me a positive answer, so this doesn't work. Which means what? This one does,
That doesn't.
this doesn't,
That doesn't.
and that does. So my answer is everything less than or equal to negative 1, or between 0 and 1. Getting the hang of that?
Yeah.
Okay, now the last kind of problem we have to look at in this chapter. All right, so here we go. Number 3. This is called projectile motion. And projectile motion is a huge piece of your calculus study, so here we go. A ball is thrown off the top of a building 12 feet tall with an initial velocity of 18 feet per second. When will it hit the ground? Now, I will provide you always with the projectile motion formula. It's written on the paper. You do not have to memorize it. Please do not memorize it. However, you are going to have to be able to build your own equation from this general formula. This is the height above the ground. So remember, this right here is like an H. It's like the height. Any guesses what T stands for in the equation? Time, seconds. This guy is the initial velocity. And you know what velocity is. So if I took a ball and lobbed it up into the air, that would be a slower velocity than if I took it and really winged it, right? Now what is the velocity in this problem?
18 feet per second.
18 feet per second. So we're just going to put an 18 there. So that's 18t. You got to be able to plug the numbers in the right spots. Taylor. It's going to be tough. It's one of the tougher things we've done. Let's really pay close attention. S sub naught, this guy here at the end, this stands for the initial height. In other words, at the beginning of the problem, how high was the ball? Well, it tells you. It was 12 feet because we were standing on a building 12 feet tall, so that's plus 12. That is your equation. Okay? Now, once you write your equation, notice there's an A, B, and C problem here. Once you write your equation, each of the questions, A, B, and C, will give you a piece of information that you will plug in either for H or for T. There are two variables here. You will always be given one of them in the question. So we got to read this question. When will it hit the ground? Now, it's asking me for T, right? Isn't it saying what's the T? So they must give me the H. What's the H? If the ball is on the ground, what? 0. Its height is 0. So for question A, we're going to plug 0 in for H. Now, those of you that are confused by that, I need you just to be logical for a minute. This equation gives us the height above the ground. If you are on the ground, how high are you? 0. Right. All right, we'll pick up here tomorrow. Have a good afternoon, good morning, good day.
Can you have 2 negatives on that? Kind of problem?
Have a good day.
What if you present yourself? I don't care.
See you tomorrow.
Okay.